All right, let's talk about one of the most useful tools in algebra, something that helps us deal with those tricky parentheses that pop up in equations. We're going to get this unlocked today. Let's dive right in. So, have you ever stared at a math problem, one with parentheses, and just felt stuck? Yeah, you're not alone. I love the metaphor the source material uses for this. Think of those parentheses as a locked gate. You know the answer you need is right there, on the other side, but you can't get to it directly. And that's the whole issue, right? Before we can start doing the usual stuff, moving terms around, isolating the variable, we have to deal with that gate. We need a way to bust open those parentheses, but, in a way that's mathematically legit. We need a key. And that key is called the distributive property. This is the official rule that lets us unlock and open up the equation. Now, here is the most crucial part. It's not just about multiplying the first thing you see. It's about distributing the term on the outside to every single term on the inside. Here's what it looks like in its purest form. You've got A on the outside and B plus C on the inside. The rule says that A gets multiplied by B and it also gets multiplied by C. I like to think of A as showing up to a party inside the parentheses. It can't just say hi to B and ignore C. That would be rude. It has to greet everyone. When it does, you get a new expression, AB plus AC. And just like that, no more parentheses. Now, knowing the rule is one thing, but actually remembering to apply it correctly every time, that's the real challenge. Luckily, there's a really simple visual trick that can help make sure you never miss a step. It's called the rainbow arrow method, and it's super helpful. All you do is physically draw little arrows or arcs from the number on the outside to each term on the inside. One arrow to the first term, another arrow to the second. They kind of look like a little rainbow, and these serve as the perfect visual reminder that you have two multiplications to do. All right, enough talk. Let's actually put this key to use and unlock some of these gates. We'll start with a nice basic example and then work our way up. Okay, here's our first problem. 2 times the quantity x plus 5 equals 16. See that? Our variable x is trapped inside that locked gate. So, step 1, we use our key. We distribute that too. Imagine drawing those rainbow arrows. We do 2 times x, which gives us 2x. Then we do 2 times 5, which gives us 10. And poof, the gate is unlocked. Our new equation is 2x plus 10 equals 16. And from here, this is just a standard two-step equation. We subtract 10 from both sides, leaving 2x equals 6. Finally, we divide by 2, and bam! Our answer is x equals 3. Okay, ready to level up? Let's try a trickier one. This time, the number outside our gate is negative. And this introduces a really, really important rule that you've got to be careful with. And here it is. This is a big one, folks. Seriously. When you're distributing a negative number, you have to watch those signs like a hawk. The number one most common mistake is forgetting this simple rule. A negative times a negative equals a positive. Okay, let's apply it. We distribute the negative 3. First, negative 3 times y, well, that's just negative 3y. Easy enough, but now here's the crucial part. We multiply negative 3 by negative 4. Remember the rule? A negative times a negative is a positive, so that becomes plus 12. Our new unlocked equation is negative 3y plus 12 equals 15. Now we're back to a simple two-step equation. We subtract 12 from both sides to get negative 3y equals 3, then divide by negative 3, and our answer is y equals negative 1. See how that sign flip was everything? All right, let's look at one final, more advanced problem. This one has an extra number just kind of hanging around outside the parentheses, even after we're done distributing. So the most important thing here is the order you do things in. You must distribute first to unlock the gate. So 4 times 2k is 8k, and 4 times 1 is 4. This leaves us with 8k plus 4 minus 3 equals 25. Now, before we start solving for k, let's just tidy it by combining the like terms. We have a plus 4 and a minus 3. That simplifies to a plus 1. So now we have a much cleaner equation. 8k plus 1 equals 25. From there, it's easy. We subtract 1, then divide by 8 to get our final answer, k equals 3. So, now that we've seen how to use the key correctly, let's talk about the common traps people fall into. Because if you know what they are, you're way less likely to make these mistakes yourself. This right here is the single most common mistake. Hands down, people will correctly multiply the 2 by the x, but then they just forget the second number. They just bring the 3 down. No, remember the rainbow. You have to distribute to every term. The 2 also gets multiplied by the 3, so 2x plus 3 correctly becomes 2x plus 6. The second trop is kind of the opposite problem, getting a little too enthusiastic with your distribution. The property only applies to the terms inside the parentheses. That's the boundary. Think of the equals sign like a brick wall. Your distribution stops there. You would never, ever multiply the 2 by the number on the other side of the equation. You might be sitting there thinking, okay, great, but when am I ever really going to use this? Well, the logic behind distribution actually shows up in all sorts of everyday situations, especially when you're dealing with groups. So, imagine you're buying tickets for yourself and 2 friends. That's 3 people total. Each ticket costs $20, but there's also an unknown service fee, we'll call it F, on each ticket. The total cost can be written as this expression, 3 times the quantity of 20 plus F. Now, if we distribute that 3, we get 60 plus 3F. This doesn't just give us a new expression, it gives us a new way of seeing the cost. It's the total base price for the tickets, that's the 3 times 20, plus the total of all the service fees, the 3 times F. It separates the 2 parts of the cost for us nice and clearly. So why does mastering this key matter so much? Because this isn't some one-off trick for a specific type of problem. The distributive property is a foundational skill. It's something you'll use constantly as you move into more complex topics, like solving inequalities or working with advanced expressions called polynomials. Getting really comfortable with distribution is like being handed a master key for algebra. It opens up a whole new world of problems you can now approach with confidence. So the real question is, now that you have this key, what other mathematical locks are you ready to open?